Hey guys, continuing on the conversation of using new notation, AP Calculus content, trying to add up or sum up the terms of a sequence, we want to get some tricks that we can use that will then apply to integrals, or at least give you an idea of what is okay and acceptable steps that you can use as you simplify summation problems that will then apply to steps that you can use when you simplify and solve definite integral problems. I'm going to do example 5.2a that says the sum of the terms, excuse me for a minute. All right, and we're back. The sum of the terms I minus 3 quantity is squared, and we want to go from I equals 1 to 200. That's a lot of terms to add up. I think I can take some shortcuts here. I go I minus 3 squared. If I write that as a sum from I equals, let me just check. I said, let me just check. There we go. 1 to 200. There we go. 1 to 200. Then, well, first of all, I believe, I'm fairly confident that I can just directly right now go to Desmos and plug all of this in. But I want to use some of the information that's there, mainly in that what's here in the argument of the summation is a polynomial, right? I can simplify by rewriting, expanding some FOIL, but I can make this become still I equals 1 to 200. I can make all of that become I minus 3, I minus 3. I can rewrite the stuff on the inside, this expression on the inside of the summation, so that I can then think about what else can I do with this? Well, I can distribute and distribute, and so I have the summation from 1 to 200 of I squared minus 6I plus 9. And so we can't really like treat the summation as applied to the square, but when you use the square on the expression, then we can have this quantity, this expression here written as that, written in terms of a trinomial. Now what we get to do is use the fact that a summation can be broken up according to terms of a polynomial. So minus 6 summation. Oh, and also, by the way, what does a 9 or a negative 6 do to adding up repeated terms of I? Every single term is going to be multiplied by negative 6. So there's 1 times negative 6, 2 times negative 6, 3 times negative 6, dot, 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 all the way up to 200 times negative 6. So this is kind of like a factor. This is exactly a factor process. The negative 6 does nothing in terms of the summation. So don't even bother calculating it in the beginning. Save it for a final calculation at the end. Summation from I equals 1 to 200 of just I. If you think about the summation from I equals 1 to 200 of 9, but 9 is not a letter I, there's really nothing here that's going to change the 9. There's no i's in this summation. So we're going to bring the 9 on the outside, but realize that this summation doesn't exist. It's not really adding up any I things that are going to change, just adding up 1. Done. Okay, let's go to Desmos because, no, do we need to? We don't need to. Check it out. There was some rules. The sum of consecutive integers squared. Here, look at this right here. The sum of consecutive, these are formulas that we can also have access to now. This one is called, I think, the handshake problem, or maybe this one is, but the point being that when you're going to add them all up from 1 to 200, but I is left alone, it's this expression. I'm not going to use Desmos at all until I check my answer. If we're going to add up the sum of consecutive integers squared, it's 1 squared plus 2 squared plus etc. It's this expression. There is a good proof behind why these work. Not the purpose of this video. We're already at 4.5 minutes. So I'm going to take the I squared, this expression, which goes from 1 to 200, and I'm just going to apply what I see right here. N is doing the job of 200. 200 times 200 plus 1 times 2 times 200 plus 1. All of that is divided by 6. That's this expression. If you can't see it, let me see if I can zoom in for you. Okay. Then we take and we subtract 6. We got to do that part. And we're going to multiply by the expression for the summation of I. So minus 6 times, go back to OpenStax, that would be n times n plus 1 divided by 2. So 200 is n times 200 plus 1 divided by 2. Excellent, excellent, excellent. Here's what it is. And then last of all, the 9 is not doing anything. So plus 9. It has the summation of a constant. Well, if the constant is 1, it's just 1. So now what we have is the opportunity to simplify all of this, get to an answer. We'll be able to add up I minus 3, that thing squared. Is there something else we could do? I'm going to try something in a minute. Let's see if it works. There's like a way you can rewrite your index. But we'll get to an answer first this way. Okay, so 200, 201, 401. So 200, 201, 401 over 6 minus 6 times 200 times 201 over 2 plus 9. And then 200. I need to use a calculator for this. My brain in the moment not going to be good. Hey Siri, what's 200 times 200 times 401?
200 times 201 times 401 is 16,120,200.
Divide by 6. Hey Siri, what's 16,020,200 divided by 6?
16,120,200 divided by 6 is 2,686,700.
Okay, hey Siri, what's 200 times 200 and, oh no, wait. I can do 100. I can add the zeros here. So this is 6 times 20100 plus 9. Hey Siri, what's 6 200? Sorry. Stop. I know. I got it. Hey Siri, what's 6 and 100?
6 times 20,100 is 120,600.
Wow, I feel dumb. Okay, so 2,686,700 minus 120,600 plus 9. Hey Siri, what's 2,700 minus 120,600 plus 9?
2,686,700 minus 120,600 plus 9 is 2,566,109.
Let's check it with Desmos. I'm off by a little bit. I need to figure out where I'm off by. Can I do it? I'll show in pieces. Maybe I'll just do like this one. So the summation from I, right? You need I equals 1 to 200 of I squared. Okay. The summation from I equals 1 to 200 of, put the negative 6 in the front, negative 6 I. And then the summation from I equals 1 to 200 of, put the 9 in the front, put a 1 in there. That's the problem. I don't know how I didn't think of that. You're doing 9 repeatedly 200 times. So if I put a 9 here and I put a 1 there, that's what I did wrong. Okay, I need to go back and fix my mistakes. So that means that I need to reevaluate my life, reevaluate how this summation is 1 to 200. Somewhere the I has to be visible. I guess you're just adding up 1 200 times, but I feel like this is still like a I don't know what it feels like. 1800, 1800, 1800, 1800. Fix this one. Okay. Hey Siri, what's 6,700 minus 120,600 plus 1,800?
2,686,700 minus 120,600 plus 1,800 is 2,567,900.
All right, let's go check to see if that's what I had from Desmos from the beginning. It is. That was the problem. Thank you for watching this video. 10 minutes. Appreciate you sticking around this entire time. If you did, talk to you later.